Welcome back. This is hopefully the last part of the series, and we're halfway done with the animation, and I think I'm gonna get it done in this video. Anyway, the next thing for us to do, in the last video we created this cool animation here. We can already rotate the rotors, that's pretty cool, but we want to have a text input and a text output, right? So what we'll do is up here, I'm gonna create an input and an output variable, which I'm going to initialize as empty strings, input and output. And now down here where we are tracking our user input, and here we are within our key, so L or else, we'll say key, so here the user is typing a letter, and we'll say key is equal to event.unicode, so that's just whatever the user is typing really on the keyboard, and we'll say if the key is in the alphabet, but lowercase alphabet, A, B, C, D, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now in that case, we'll say that the letter is equal to key.upper, so we are converting that into an uppercase string, and then we'll say that our input is equal to input, whatever that was before, plus the letter. And for now, we'll say that the output does the same thing. And of course, later on, right here, we'll introduce the Enigma encryption, right? Because the output is not supposed to be the same as the input. And right now, let's just say print input to see whether any of that works. I'm going to run this, and now I'm going to move this up here and start typing. Event.unicode is not working. That's because it's not a function. So let's run this again. Okay, I'm typing, I don't get an error, and here I'm just repeatedly typing the letter F, and you can see how the input and output messages are getting longer and longer. Well, it's actually just the input, but the output is the same thing really. And now we gotta draw that to the screen. So I'm just gonna go into, say, my rotor class, and here I'm gonna steal this bit here, which is where we are working with our fonts. So here I'm now going to say text input, and now we'll have our text, and we are rendering our input. I'm going to make this white, for example. Now we have a text box. Now the text box, I want this to be in the center of the screen, so I'm just going to say this is width half, and the height, well, we're gonna use the margins that we have created, so margins, and we'll use the top margin, and we'll divide that by 2 as well. And then, well, we'll just say screen blit, whatever it was, here screen.blit, our text in the text box. Let's run this. Invalid syntax, screen.blit. What's the problem here? I'm missing another parenthesis, maybe? Font is not defined. Yeah, right here. This has got to be, let's work with bold for the moment. Letter is, this is going to be text. This is what you get from copy pasting. Screen, same problem. Uppercase. There we go. And there we go. I can now type on the screen. Nice. And let's do the same with the output. So let's go here and text output. But here I'm just going to use our mono font. And I'm just going to, well, now we got to increase this, right? Because otherwise they should be like right on top of another. Okay, this is actually not working. What's the, okay, here, output. Let's run this, and now they're kind of stacked on top of another. So what we'll do, we'll just add plus 20 maybe. This is not working. Yeah, gotta be here within the tuple. And there we go. So now you can see how we have our input and our output, but of course right now it's the same thing. Maybe make this 25. I have a tendency to play around with the values for way too long, but I think this looks pretty. All right, so we have text input, text output, and the Enigma machine. So right now, the only thing that's really missing is our encryption path. And to visualize that as well, I'm now going to add another variable up here, which is our encryption path, which will be a list. And for now, it's an empty list. And now, whenever the user types a key, we want the Enigma machine to do the following. We'll say the Enigma machine is going to output two things in the future. First, it's going to output the encryption path of this letter, and then it's also going to output that letter itself. So, which I'm just going to call cipher actually. And here we'll add the cipher to the output. And this is now what happens when we use our Enigma function class, and here the encipher function, enigma.encipher, well, that input letter, right? And then we'll add this right up here in our draw function. We'll add the path, and then we got to do this here. So we are not only visualizing the Enigma machine, but also the path. So here I will say Enigma components. I'm going to call this the base coordinates. Well, W and H, I think they really more refer to this down here, the Enigma components. But you know what, I'm just going to leave it up here. Base coordinates and Enigma components. Okay, let's run this. No. Already an error. Yeah, because we are not enciphering anything yet, right? And it's returning two things, the path. Right now, yep, this works. And now it's time that the Enigma machine does not only output the letter, but the entire encryption path. How do we do that? We go right into here. And where is that? Yeah, here. We are passing the signal. So let's create a path, which is an empty list. And here we'll now say that we have our new signal. And our signal initially, it's the input letter, it's the keyboard, it's this signal, and then we move over there and so on, right? So here we'll say that path is equal to, that signal. So we don't really need this. And now we can just say path.append that signal. And the path should now get longer and longer with every step through the entire machine. So we're really saving that entire encryption process. This is getting long. There's probably a smarter way of doing this, but I'm too lazy at this point. And now I'm returning both the path and the letter. So let's see if that works. Running this, we don't get an error. This looks good. And you know what? Let's print out that path. So I just typed a letter, and now it says that we are, okay, I want to start with an easy letter. So I'm going to print an A. Okay, there we go. And it's enciphered as an O, that's good. So 0, we start on a 0, and now, well, we are carrying that over, and it becomes a 1. So we go into the M, go down here, carry that over, and I think that's looking pretty good. Now, at the beginning, I want, yeah. No, this is good. This is the encryption path. 14, yeah. And now it's time to visualize it. We now have to turn this into X and Y coordinates that we can draw onto the screen. And this is actually somewhat tricky, but we'll get there. So let's get rid of the path. Okay, actually, let's print the path once more. I think it would be advantageous with our coding if we included this 0 here twice, once for the keyboard and then once for the pluckboard input. And then we have the 1 twice for the pluckboard output and the rotor input. So what I'm going to do is I'm going to go into the Enigma machine, and now I know that this is now going to look crazy, but we'll have the inputs. We have this here twice, and now I'm going to do this twice. I know this looks super weird and it's getting kind of long. What you could do, you could incorporate it in the forward function as well, such that the forward function does output the entire path, but I don't really like that. So I'm just going to do all of that here. So let's run this again, type A, let's see. So 0, 0, then we swap down here 1 and 1. Now comes 18, which is down here, which is carried over to this Z. 25, now the next 25, this K, which moves up here to this 8, is carried over. Okay, now the reflector is kind of tricky because now P is changed to 15. And now we have 15, and here we need 15. The way that we want to visualize this is we want to have 15 highlighted here and then once more here and then maybe with a change in color. We don't have to do it this way, but yeah, let's just leave it as is for now. So 15, now comes 21. Where's that? It goes down all the way. R down here, then carries over, and then 14, 14, 14 in the end, which is the O. So I think this is the plugboard 14. This 14 here is right there. This one is here, one there, and then, okay. So let's draw these coordinates. So I'm going to go into draw, and here, here I'm not going to say draw path, okay? And here, draw Enigma components. Now with the path, what are the y coordinates and what are the x coordinates? We got to figure that out. Now with the y coordinates, we just have to turn all of these signals down here into coordinates depending on how far up or down we are. And that is actually not too hard. The problem really is really the x components. With y, we can just say for every signal in the path, well, they all start from the top with our top margin. And then we gotta add signal plus 1 times, this is really similar to the way that we have drawn the components in here with I plus 1 times h over 27, so the letters within the components. So I can just copy this from over here. So we have signal plus 1 times h over 27. And so now I'm going to have this up here as well. Okay, so here x and y are used for the machine components, and here this y refers to the path. And here I'm going to say width and height of components. So let's see if that works. Let's print y. We have a syntax error. Margins top. Yep, this one here is unnecessary. And I think it works because down here the computer, like crazy, for every frame of the animation is now printing out these y values. So what are the x coordinates? The x coordinates, well, the first x, if we have a look at this chart here, the first x is really all the way to, it's really the right-hand side of the screen, and then we subtract from the width the right-hand side margin, and then half the width of the component, right? So here we can just say that this is the width minus, remember we are in the local environment of our function here, so lowercase width minus margins right minus width half, and with the width now just being w, which is the width of the component. So that's the first x. Now the next x is really this bit right here, right? So now we have to add to the current x, we have to add, we have to add the gap size, right? And we have to add half a width and then just quarter of a width. So 3/4 of a width of a component width and the gap size. Okay. And maybe we can program this in a way so we don't have to hard code it for every single component. And what we can do is we can say so this is now really the forward pass through the machine. So we can say for I in, not range, but here, no, we'll just say 4, 3, 2, and 1. We can now say append to x. Yeah, so we are coding this backwards now. So we have 4, 3, 2, 1. And we are now thinking this from the left. So width and gap, we have this once, twice, 3, 4 times. So we can now say that we have, well, we have our left margin. Let's not forget about that. Margins left plus I plus 1 times width plus gap. And now we have to add width 3/4. And then we have the same thing backwards. So here we now have 1, 2, 3, 4, but now it's times 3. Come on. Times 3/4, and here it's just 1/4. And now it's really only the reflector in the middle. And the reflector, if we go back up here, well, actually, no, let's go here and type an A. Now the reflector produced, where are we? That's the plug board. So that's, no, that's the keyboard. Plug board, 1 rotor, 2 rotor, 3 rotors. So this is 8 and 15. It's really just like one of the rotors, the way I'm doing it right here. So maybe I can get away with just throwing in a 0 in here. Okay, let's run this. This is our A. And down here we have our path. And I did not get an error, so let's just see what happens if we now try to draw this. So we have our x and y coordinates. So we have the coordinates. So I'm just going to call this, path coordinates, right? Now here we'll draw the path. And here, okay, base coordinates, I don't care. So for I in range, we have 20 coordinates, remember? So make this a pass. Go here, type it's 20, trust me. But here, I'm going to prove it to you. So that's 1, 2, 3, and so on, all the way up until 20. You can count this, it should be 20. And now we'll say we're not going to start with the first, but with the second coordinate here. We'll now say that the starting point of the first line is equal to a tuple xi minus 1 and yi minus 1, whereas the end of the first line is equal to xi and yi. It's not the first line of every line, right? We have start and end point. And now we'll say pygame.draw a line onto our screen in, let's just make this a red color. And from start to end, let's specify a width equal to 5. Now let's see if that works. List index is out of range. Well, at first there is no path. Path has no length. So we only do that if there is a path. So, well, if length of path is greater than 0, only then are you to actually draw the path. Okay, there we go. And list index out of range. That's too bad. So let's print I and see what the problem is. So 1, 2, 3, 4, 5, 6, 8, 9, 10. What's the problem with 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's got to be a stupid mistake here. Right, the problem is I only always added the right-hand side components here. The right-hand side alphabet, the x coordinates of the right-hand side letters, so to speak. So here I gotta copy paste this line here in our draw script with a quarter of a width, and now down here with 3/4 of a width. Okay, another problem here is I forgot to add the x coordinate off the lamp board. So here, this is the forward pass, this is the keyboard. Now comes the backward pass, and this is now the lamp board. And the lamp board is the same as the keyboard, really. Okay. List index out of range. Oh, come on. Easy problem here. Well, I gotta append this, right? Not replace x. So, x.append, all of that. Okay, that's our first path drawn through the machine. There are still some bugs here, but okay, what's the problem here? Oh, come on. We were so close. Okay, an obvious mistake that I made here. This is not 1 plus gap. It's just like almost a typo. It has to be the width of the component plus the gap size. Okay, let's see whether that fixes most of the problems. And there we go. So this is now looking a lot better. It's just shifted over by 1 position here. Almost there. So what else is the problem here? Minus width half, minus width half. We are starting correctly. So the first problem that I can see here, and this is just because I was like copying, pasting my idea here, I gotta make this I, not I plus 1. But I don't think this is gonna fix everything just now. But to make our lives a little bit easier, and because it looks prettier anyway, what we'll do is we'll change colors as we are drawing the path. So we'll say color is equal to red if I is less than 10 and else it's going to be, we'll make the forward pass green and the backward pass we'll make that red. And because the standard colors don't look all that pretty, I've come up with these values here, which I think look a lot better. So I copy pasted these over. So here, there we go. So let's run this and type a letter. And okay, the color changing, well, I've got to use it actually. I just pasted this right here. So here we got to use our color. And let's see. There we go. So this is starting to look good, but the backward pass has a problem. So here, there we go. We go all the way up here. Then you have to have a reflector color. And then this is why I said I kind of wish, like when we reflect, I want this to be yellow and then this to be yellow maybe all the way up until here, and then it's red. So we might want to add in an additional coordinate here with the reflector, but we'll do that in a minute. So we're going back over here, and now suddenly we're jumping all the way over there, and that's a problem. So backward pass, this is right here. 1, 2, 3, and 4. I guess here's the problem. Indentation error. This has to be out of the loop. And there we go. Now we have it. So let's introduce the reflector as its own color. And then we should be done. So, okay, let's make this if I is less than 10, color is equal to that. Then we'll say if I is less than 12, and then we'll have our else, and here color is equal to this, and let's figure out what color is equal to right here. And within the reflector, we now want to, well, go into the Enigma machine, and where's the reflector? Here's the reflector, and here we're just going to add our output signal no, not before the reflector, after the reflector. So here we're going to add it one more time. No, come on, no, I was right the first time. So we're going to add it one more time. I know that this looks super clumsy and there is a better way, I know. But yeah, I'm lazy. So we just added this in one more time. Go into the draw function. So we have our path. So I'm just going to take this. Margins left plus width times 3/4, and that is the reflector, if I'm not mistaken. And now I'm just going to make sure that this 12 here is correct. So 12, yeah, that is correct, but here we now got to change this to 21 because we added 1 point. I'm going to copy over another color, and let's see if that works. And there we go. So yeah, now we got it coded. So here's an A as it travels through the entire machine. See? We now have the entire encryption path lined up. So the A enters the plugboard as an A. We got to add some some, well, just little titles here that explain which component is what. We'll do that in a second, but for now, let's just trace the path. So A comes in as an A in the plugbboard, gets enciphered into this position right here. Now we move it over this position, we carry it over, we go down here, carry that over, go down here, it's a Z now. Here, K, P, go out of here, and now it changes colors. Enter here as an R, go down here, V, back to R, O, and O is not changed in the plugbboard. We output that. So yeah, let's type some more letters, and you can really see how awesome the animation now works. So notice how we now have the U in the almost top position. Now I'm going to type another letter. Now it's in the top position, and now it should knock over that rotor here, and boom, there we go. So you can see how this just worked. So let's do this one more time. Now the U's in the top position, knocked over that rotor, and the next time that we come along, I'm going to move my mouse over here. Yeah, we already moved this because of the double step anomaly. Yeah, there we go. So let's add the names of the components. How did I forget about that? Where do we, well, draw the Enigma machine. And now, well, text output, well, we're going to do that here. Draw the path and base coordinates, draw Enigma components, and here add names. So for name in, well, we have the reflector. We have, I'm just going to call them left, middle, and right. Now we have the plugbboard, and lastly we have our key/lamp board. And well, we'll just call this names, and then we can say for I in range 1, 2, 3, 4, 5, 6, can say that X is equal to margins left plus and then, well, W half, I think. I think that should be it. And then somewhere, I'm going to go into our rotor here, and we'll steal this bit here. Copy, paste it down here. Text box is equal to names I.getRect, a center around X and Y. And Y is now, well, we're going to make it margins top and then maybe times 3/4, well, 80%, something like that. We'll play around with that, and then we'll blit that onto there. So you know what, I'm gonna make this just a Y and define Y up here. So let's see if that works. We get an error. So the problem is that names I, we got to render that first, right? It's not rendered. So here, let's just take this, go here. So title is equal to font.render, not self-notch, but names I, and then text box is the title around that. And here, let's just use white for now and see what that looks like. Letter, that's just a copy-paste error. We want the title to be drawn, not a letter. And now it's, of course, all overlapping up here. What went wrong here? I forgot to increase my X. So this has to be, okay, let's do it this way. Margins left, and then say X plus equal I. And yeah, we have to add the gap size anyway. So, you know, I'm going to move this up here actually. And now with every component, we'll say I times W plus the gap. Is that correct? No, it is not. So what's the issue here? Well, not I, just width and gap, right? And now it's shifted over because it has to be, well, because the reflector is already shifting it, right? let's just do it this way. X is equal to this plus I times width plus gap. So that should be it. Oh, come on. This was a lot harder than I thought, just adding a bunch of names. So here's our keyboard, left, middle, right, plugboard, and reflector, and here's keyboard and lampboard. And now let's type coding category. Oh, we're missing spaces, right? And maybe we have to move this down a little further even. So draw. Let's make this times 0.8 maybe. And in our main, we'll say if event.key, elif event.key is equal to pygame.key space, k space. We'll then say that our input, we'll just add a space here, and same with the output, but we don't bother with, you know, the cipher here. And we can't forget about this print here. Let's run this again. So coding category. I still feel like this should be up a bit further. So I'm now really just playing around with these values, right? You totally don't have to do that, but I like things to look at least somewhat pretty. So where is that? The input is drawn all the way over here. Track input and output. We'll make this maybe a third. No, not width here. Third. Run this test, and I think, yeah, this is now what we want. So test, 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 and yeah, that's really it though. I mean, we have implemented the machine. You can type here as much as you want, and the animation, I think it's quite beautiful. You can see the full encryption path, and if we keep on typing, you can see how the rotors advance and how they kick off the next rotor and so on. So let's make this advance once more. So we're right here, kicks off this rotor, kicks off the next one, and I think that's pretty cool. And yeah, so this is our machine. Everything is now done. Yeah, we can code our own messages. I'm going to code coding category one more time here. Will this be the perfect machine? I hope it's as close as possible to the real thing. There may be a bug in this or some kind of peculiar thing about the real Enigma that I have not considered here. So it may only apply to parts of the real Enigma machine. I hope it's as close as possible. So if you spot something that you would like to let others know about, so just use the comments underneath the video. Just leave a comment. Also leave a comment if you like the video. This is also very nice to see. And yeah, come up with your own designs and introduce a 4th rotor, a 5th rotor, go for 10 rotors, go for 100 rotors. Obviously this will be kind of hard with the animation. But yeah, experiment with rotors that have 2 notches. Some of the historical rotors had that as well. I did not implement this here, so you might want to add that too. Play around with the colors, play around with the animation, make little adjustments here and there, and let me know about all of that in the comments. Thank you very much for watching this video. This was a pretty fun coding project, I think, and yeah, I'll see you in the next one. Bye.